Hi everyone, I've had a request to solve question 2D from the 2019 NCEA mechanics paper, and I've just printed out that page. The question looks like this. I'm just going to read through it so that we know what it's all about. So this is about a team that's waiting on the sidelines. Two players sit on the bench as shown. So I've just drawn this here. The bench is 1.50 meters long and has a mass of 10 kilograms. Each player has a mass of 60 kilograms. Player 1 is 0.25 meters from end B and player 2 is 0.60 meters from support B. So they've got two supports, A and B. Okay, we've got to do two things here. One is draw labeled arrows showing all the forces acting on the bench. So now this is how you determine. So there are three forces acting downwards. So two of them are quite obvious, but the third one we may not always think of it. So the forces would be the gravity force or weight force of this person acting downwards. So there's Fg, which is mg, m1g. And then there's this one's too, similar, Fg equals m2g, because they've got same mass. And then there's a third one, and the third one acts through the middle of this, which is the mass of this. So its weight force acts downwards. So this is m2g. So you can't have only forces acting downwards, you also have to have forces acting upwards. So the two upward forces would be from whatever is resting on the ground. So what's resting on the ground are the supports, and there are two of those supports. The sizes of these are not necessarily going to be the same because there's more forces acting downwards on this side, however. So this is Fa, and that would be Fb. Ideally, if you're quite pedantic, the size of Fa plus Fb should be equal to the sum of all those sizes. So these actually have to be quite bigger than those ones. Okay, so we've done the arrows for the forces. And the next thing is, by first determining the torques about point B, calculate the support forces at each end of the bench and what assumptions have you made. So looking at the assumptions, I'm going to assume that this bench is a uniform bench, and when I say uniform, it means its mass is equally distributed so that the weight of the bench acts through its center, so it could be that. All right, so let's take, so this has to do with, these have to do with conditions for equilibrium. So there are two conditions for equilibrium. So one is the total force up is equal to the total force down. So we say it's in linear equilibrium. And also this bench is in what we call rotational equilibrium. That means it's not going to swing about. Okay, so for rotational equilibrium, so we say that the sum or the total of the clockwise torque equals the sum of the anti-clockwise torque. And the formula for torque is force multiplied by perpendicular distance. Okay, so let's first of all figure out which one's clockwise and which one's anti-clockwise. Now we're treating E as pivot, treating B as the pivot point. We're going to say that the sum at equilibrium, the sum of the clockwise torque equals sum of the anti-clockwise torque. And maybe I can just use green probably. Okay, so what I do is from end B, I'm going towards that arrow. So that's anti-clockwise, that's anti-clockwise, that's anti-clockwise. Can you see? So that's your torques. So these are three anti-clockwise torques should be equal to, from this end, there's another one, clockwise torque. Okay, so how do I write that down? So torque is force times distance. I don't know this force Fa, times the distance is this whole distance, times 1.50 meters is equal to, so start from here. This is the mass of this whole thing is 10 kilograms. So I have to convert it to a force times 9.8 times the distance is going to be half this distance. So half of 1.5 is 0.75. So I've got one set of torque, and then the torque because of this person, so plus, he's 60 kilograms times 9.8 and he's 0.60 meters from the end. And then the last one is also 60 times 9.8 times 0.25 meters from the end. Okay, so that's how I get this equation, and then I'm just going to solve this. So I'm going to get 1.50 times FA equals, and where's my calculator? Is just here. Let's get some numbers over here. 9.8 times 10 is 98. So 98 times 0.75 is 73.5. So this whole thing becomes 73.5 plus 60 times 9.8 times 0.60. 60 times 9.8 times 0.60 equals 352.8. So I get 352.8 plus, and then the last one is 60 times 9.8 times 0.25, and I get 147. So 147. I'm going to add all these three up. So I get 1.50 times FA equals, that's 147 plus 352.8 plus 73.5, and I get 573.3. So that's a 573.3, and so FA is 573.3 divided by 1.50. So if I divide that by 1.50, I get 382.2. Okay, so that's newtons. Now that's how you get the answer for FA. Now how are you going to figure out FB? So for this, we say that the total force up equals total force down. So in other words, the total force upwards is FA plus FB equals, the total force down is 10 times 9.8, it's mass of this, plus 60 times 9.8 times 2. There are two of them, right? Okay, so we don't worry about the distances, just the forces. And now we also know that FA is 382.2 plus FB equals, can you see what I'm writing at the bottom? You can, we're nearly there. So 10 times 9.8 is 98 plus 2 times 60 times 9.8, I get 1274. So that's the total force acting downwards. So FB, I'll just do it over here. So FB is 1274 minus 382.2, and that's the answer for minus 382.2, and I get 891.8. So 891.8 newtons. So that one's 898.8, fair enough, because it's a bigger force upwards to support all this, and that's a smaller one. So that's how you do question 2D from the 2019 NCEA Level 2 Mechanics paper.